Okay, so at this point, after having our first grasp of how functions and callbacks are working, let's move on and see how some of the callback mechanisms are already implemented in the JavaScript standard library. And basically all the methods that go under the name of functional programming or functional paragraphing. We'll see basically now the functional methods for arrays, but the idea of functional programming goes beyond that. The idea is that we exploit the fact that functions are just objects that can be passed around and called through variables normally. And so we can have a function taking a function as an argument, or a function returning a new function as a result, and so on, all sorts of stuff. So actually, what we are thinking are, there are functions that do stuff, and functions who manipulate other functions. So we may call them higher order functions, okay? A function that doesn't know what to do, but it can perform a task by manipulating other functions. And this actually is a combination of the usage of callbacks for specifying to a given method what we want it to do, and a careful selection of the return result of a method. Usually we will have methods that build some result and return it, that can be changed with other methods that take that result and do something else. And in all this chaining of function calls, we normally try to be careful not to have side effects. Not having side effects means that every method will return a new value starting from its argument. Okay? And so every time we return a new value, that result can be the basis for application of other methods and so on. So a method returns an object of the same type of the object it receives, but it's a new object. Normally we do that. Okay? We will even be stronger about this rule of always returning a new object and trying not to modify the current one when we go into the React programming, because that would be actually the key for the asynchronous behavior. The first rule we try to apply is avoid mutability for that. So try to have a function that receives some arguments and computes a value. Never mutate, never modify your own argument or the object that you received. Of course, this from the point of view of the performance is not very good, because, for example, if I have an array of objects and I need to add a new object, the normal thing to do is just to add it to the same array. You do a push and you're done. But in this way, you are modifying an object. In that case, your function will have a side effect of modifying some objects, and so it cannot be interchanged, it cannot be chained, it cannot be called in an asynchronous way, because when you are modifying something and you are not sure in the order in which the operations are happening in asynchronous programming, that could create problems. So in this case, what we would do is to take an array and return a new array by copying all the old elements plus the new one. Okay? So we can understand that the performance is worst, because we need at least to copy an array into a new array. We need more memory, we need some time for doing all these copies. But the advantage of being able to deal in an asynchronous way with multiple operations offsets normally the performance issue. At least we still apply the old rule that we should never optimize for performance before the program is complete and correct and debugged. Okay, so let's not bother about this for the moment. It will be strange sometimes. Okay, I can just modify this. No, you should return a new one. And so, what are the methods that are already defined, and then later on we will learn how to define our own for other data structures, on arrays. Basically, we have these 5 methods, plus 1, for each every sum, map, and filter, and reduce. How do they work? Actually, for each is an implicit loop construct over an array. So, for each is a method of the array object. So we have array.forEach, and the argument of this method is a callback function that is called for every element of the array. Okay? So, for example, let's take our example that you've been working on the question and answers. Okay, we had, for example, I wanted to print the list of answers, okay? So we can add question 1 is being printed at the end. Sorry, it's here. Okay, we have the object question that has been printed with a list of answers. Okay, so this print out from question is the output of this log statement that prints the object Q1 with its properties, question, username, date, and the answers property, which on turn is an array. So what do we want, for example, just to print the names of the people who answer to the questions? Well, we could do that by taking the names out of the object is Q1 dot names. We don't have any, in JavaScript, any getter and setters. We just access the property because there are no protection mechanisms. Sorry, not the names, answers. And for each answer, we want to print the name. So in a normal way, it will be a for loop where for each answer, we print answer.username. In functional programming, we would take the array names, and for each element, we execute a function that does something with that element. And this function, we normally write it as an arrow function for compactness, takes one argument, which is the object that is being iterated over, and a body, which is the operation that we want to do. For example, the object will be a single answer, A, and what we want to do is to print console.log the name, a.username, for example. Okay, so we have, if I run it, I should see, I need to save it, sorry, and run it. What's that? Sorry. Okay, here are the list of names that they have at the bottom of the console. So actually, what I did is to implicitly say I want to iterate over this array, and I provide an action to do element by element. So the callback will receive the first element, the second element, the third element of the array, and then we can do whatever we want with this argument that is called A. You can call it as you want. Theoretically, you could also use this for changing, for modifying the object in some way, but we try not to do that, okay? Actually, the for each method expects the callback function to receive out to 3 parameters. So actually, the for each method calls my callback that I write. I'm providing the callback. For each calls my callback by passing 3 parameters. Okay, the first one is the value of the current element. The second one is the index, starting with 0, 1, 2, 3, of the position of the element. And the third one will be a reference to the array itself. So this means that inside my function, we may have I, and the names if I want. And this means that I could wait, I need an extra parenthesis. So we have a couple, we need to be careful. We have a couple of parentheses for the for each function call, and then we have the parentheses for the arguments of the callback, the other 3. So I could write printing each name with the index in which it appears. Okay, sorry, I need to save always. And I see 0, 1, 2, 3. So if I need inside this body the object that I'm the part of the array, I have it as a 4th argument. If I also need its position, I can extract it by receiving a 2nd argument. For some reason, this names array, if I need it, would be the same as the array on which names has been called. So the original array on which I'm iterating. It's needed if I need, for example, by checking the value of one element, I need to modify some other element. So I need to index that array and have the reference to the array itself. Okay, it's seldom needed. The for each method will always pass me these 3 values, and then it's up to me to decide whether I want them, I need them or not. If I don't need the array, I can just leave it out. Okay, there's no check about the number of arguments that I'm passing to a function in JavaScript. So if I calling a function by providing 3 arguments, and the function only defines in the argument list 2 of them, well, only the first 2 are considered, the third one is ignored. And conversely, if I have a function that needs 4 parameters in its definition, and then only passing 2 of them, there's no error. The function will get the first one, the second one, and then undefined for the other 2. Okay? So we can always check if the argument was given or not. I can call a function with a variable number of arguments, just know that. So for each is a way of looping through the array if I'm sure that the loop will be completed. No? There's no way of doing a break or a continue or something inside a for each method. So once I start the iteration with for each, then it needs to go up to the end. The return value of for each, and it's strange, it's an exception to the functional programming paradigm, doesn't return anything. So actually it returns undefined. The result of this for each method is not defined. This means that actually for each can only be used to create side effects, to modify something, to print something, because it doesn't have any return value. Okay? On one hand, the return of for each is always undefined, so it doesn't return anything. And on the second hand, the return value of the callback function is not used, is ignored. So it's standing aside from the other methods. Is it more compact or more useful to write like this, or to write for a of names console.log username you decide. It's the same. Theoretically, they should exactly do the same stuff. Let me check if there are no errors. Yeah, there are. A is not defined. Sorry, let const. Okay. So it's just a syntax. The other methods are more useful. Where are they? The other methods are, two of them are Boolean methods. So they return a Boolean value, which is true or false depending on the result of a check of a Boolean expression over each element. So actually, every checks whether every element in the array satisfies a given property. And how do I specify the property? I specify the property by defining a callback that will check for the property itself. So every will iterate over the element, call the callback for each of them, check whether the callback returns true or false, and if all of them return true, it returns true. The general value will be true. If at least one of them returns false, then the general value will be false. And in this case, it will interrupt the iteration. At the first false element, it will return false, and there's no reason of going forward. The other question? Yep.
The previous slide, for each doesn't return anything, right?
For each doesn't return anything.
So every change will be done in place, right?
Or outside. Meaning, you're saying that if for each doesn't return anything, if you need to change something, it should be changed in place, or you could maybe modify some other data structure, not necessarily the one that you are iterating on. Okay. For example, I used a console.log. I could print into a file. I could create something else, but outside the current data structure.
For example, I have an array with integer elements.
Yep.
And with for each, I can, for example, plus one in each element.
Yeah, so just for the recording, the example was if an array of numbers, I want to increase these numbers, I wouldn't use for each, I would use map for that. Okay. If I need to return something, let's use a method that returns an array. Okay. So every and some return only just a single Boolean value, according to whether some property is satisfied or not. So we want to check, for example, that all the answers have a score, for example. Okay? None of them has been forgotten. So we want to check whether all have scores. And how we can do that? We can iterate and check for each of them if the score, what's the name of the property again? Score, yes, score is defined and is different from 0, for example. Okay? So I can do that by iterating over the answers, q1.answers, dot every one of them should have the property of being different from 0. Okay? So it means that I take an answer, A, and I return an expression that is true if the score is defined. So it means that a.score is defined and a.score is greater than 0. Okay? So the double question mark tells that if this is undefined or null, then return null, which is considered false as a return value. Otherwise, return the value of this Boolean expression. And let's see if it does the right thing. It's telling me it is true. All of them have some. Let's check. Let's put a 0 somewhere and run it again, and it should tell me, sorry, it should tell me that now the property is false, because at least one element doesn't have the property satisfied. Okay, so all the cases in which you are, using a flag to check for something, for search for something, you can use just these two methods. Of course, they are the dual of each other. Let's restore the 5. Yes. They are dual for each other. They work on an array, receive a callback, and return a Boolean. Okay? The fact that these methods can stop the iteration when they want is one more reason why they shouldn't modify any other value. They shouldn't have side effects, because we don't know how many elements will be visited. Theoretically, there's no guarantee that, well, we know that the iteration will be in order. But think in parallel. We could also do this test in different CPUs and then combine the results. The functional methods allows you to think about, okay, this thing needs to happen. I don't care about the order. Okay. Then we have probably the two most useful functional methods, map and filter. Map takes an array and builds a new array with the same number of elements by transforming each one of them, each element, with a given rule given by the callback. Okay? So imagine, okay, I was caring about the names of the answers. So I only want the names. Okay, so answer names. I want a new array that I can build from the array of all the answers just by extracting one field, for example. So it's very common to say, okay, I have an array of objects, so let me give an array of numbers or an array of strings in this case. So it would be something like q1 dot answers dot map. So what does map do is to iterate over the array, take each element, and build a new array where each previous element is replaced by an expression. That usually this expression depends on the previous element, of course, on the argument. So it could be something like a.name, username. So in this case, we can just print these names and see that I built an array with the names. If I did that with the scores, I could build an array with the scores and then compute the average or compute the sum quite easily without doing any iteration, for example. Well, letting the functional method do the iteration. So usually map is done for transforming an array into another array where each element, the constraint is the second array will always have the exact numbers of elements of the previous one. Normally, the transformation would be element by element. So I would be able, the callback normally will only see one element at a time. So it doesn't know normally where this element is and which are its neighbors. Okay? Well, that's not true, because the map also has some, the map callback also has some extra parameters like the index and the array, like we did with the for each. But we normally try not to use this information. Otherwise, it wouldn't be a proper map operation. So we use map for extracting maybe only some information from a more complex data structure. We use it for building a complex data structure starting from a simpler one, and so on. Okay, but normally this is very useful, just extracting a field from a data structure. If I wanted to compute, for example, the average of the elements, we know how to do the sum. Remember, we did it, but we mat.sum. But we know we need to do only the sum of the scores. But we don't have the scores somewhere. They are distributed throughout the array. So if I wanted to do the average, I would try to do the sum of an array. We use the spread operator because the sum needs a set of individual parameters, and then we build the array q1.answers.map. We want only the scores, a.score, and then we divide by q1.answers.length. The length of the answers is the same as the length of the scores, for example. So in this case, we have this one would be an array like the one at the bottom here, but only with numbers instead of names. So it should tell me and will tell me an error, so probably. Mat.sum. What was the function again? No, we didn't have, sorry. It was the missing one. What we did last time? Was minimum? Okay, sorry. My mistake. I remember max instead of minimum or maximum. So let's say maybe the minimum score, okay? Because mat.sum doesn't exist. We'll see it with the, so for example, like this. We'll reduce how to use it. Okay, the minimum score is 3 in this case. So it gets all very compact. Here we are looping, computing a minimum, so we don't have any variable that we are updating, any check, any iteration. And we need to, I would say, train our eyes on this operation. .map, callback function, and let's focus on the callback function because it's telling what we are doing here. So this is one operation, transforming one array into another array of the same length. The dual operation is selecting some elements of a given array without modifying them. So filter or reduces the number of elements, only selects some of them, in particular those who match a given criteria. So for example, I'm filtering here all the elements x with x less than 3. So all the small elements would be returned as an array. In the second case, in the filter case, the array will be exactly of the same type of elements that we had before, and actually the same elements. I'm not making a copy of the element, I'm just returning a reference to the existing ones. So I'm making a new array with a subset of the elements. And the elements are not modified at all. The callback will return a Boolean value just by saying, keep this one and lose the other one. True, keep it. False, lose it. And I assemble them in a single array. So do I want to make maybe only the names of the people who got a score greater than 4, greater than 3 or 4? Okay, so let's filter and then map. Okay, so the names, the good names of people who got a good score are q1.answers dot filter. Let's select those who have a good score. A dot score greater than 4, for example. And let's see how it looks. Sorry, not console.log. And in this case, it will print a list, sorry, an array of answers. This is my statement, the console log at line 76. You see I have an array of answer objects. Answer, 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 and so on. And only, you see that there is not the full list, it's only the ones who have a score greater than 4. It's 5, it's 5, it's 7, and so on. So filter created a new array of the same type, an array of answers, but only with a subset of elements. And then from this, I only want the names. So I would do a map at this point. Since I'm returning an array, I can call map over the array by selecting the username only. And so if I run this, I will only get the list of the names of people who have a score greater than 4. So we can combine them easily. Of course, you need to filter before mapping, because after mapping you don't have the score value anymore. But of course, you can do that with a loop, of course, but then you have some index variable, you have some variable, some Boolean flag, and so on, that you need to keep track of. You have a temporary array. Also here we have a temporary array, because with filter I'm creating a new array, with map I'm creating another array. It's been created and then thrown away after the execution. But it's all done by the interpreter. I don't need to explicitly declare variable and so on. Okay? So when doing some, simple manipulation like this, it becomes very handy to use this sort of functions. And the last one, which is the strangest one, is called reduce. By the way, every and some are a special case of reduce. Every and some, what they do is to return a single value, which is a basic a Boolean value, by computing a single value Boolean for every element and then combining them all. Every makes AND operations, sum makes OR operation between the operands. Okay? Reduce is the generalization of this concept. We want to compute one value, one single value, out of a whole array. For example, the sum of the elements. And this value will be computed by taking a single value from each element and then combining them in some way, for example, by adding them. So reduce receives a callback function, wants to receive a callback function that has at least two arguments. One is the current value, of course, of the element that you are iterating, and another would be the accumulator, so the value computed so far. Reduce will tell the callback, dear callback, up to now we computed 17 and the current value is 4. If we are computing a sum, then the callback will return 17 plus 4. And the 17 plus 4, that will be 21, will be the new value of the accumulator for the callback that will be called on the next element. So the callback is called for every element. The return value of each call would become the first argument of the callback for the next element. So we are changing the values. Every callback will know the result computed by the previous element. Previous element's callback. And the first one, what is the first value for the first element? Since every callback receives as an accumulator in the first argument the return value of the previous callback, what about the first one? About the first one, we have a second argument of reduce, not of the callback, that sets the initial value for the accumulator. So this is good for doing sums that the math library doesn't have. So I have all the scores. So let's say all the scores. I know how to do that. Just q1.answers.map a.score. So this is an array of numbers. Okay. Let's make several steps. The sum of scores can be computed by taking the array, reduce. So we take one array and return one value. In this case, it should be a number. Reduce. Reduce will have two arguments. The second one, we are computing a sum, so we need to accumulate numbers starting from 0. So we start from 0, which is the second argument of reduce, and the first argument is the callback that takes two parameters. The callback takes two parameters. One is the old value, the sum, and the second is the single element, E. Let's call it single element. And it returns the updated value for the sum plus element. That should be 31. Okay? So we are calling this callback many times. The first time with the first argument 0 and the second argument the score of the first item, and is 5. So the first time we are calling this with 0, 5 as arguments, and it will compute 0 plus 5, which is 5. The second time around, the score would be, so this was the first one, 5, the second one is 3. So the second time we call this callback function, we get 5, which is the previous value, and 3. So we call this with 5, 3 arguments, and that will compute and return 8, and so on. And finally, the result returned by the last callback will be the overall return value of the functional method. Okay? So, since the math library doesn't have a sum function, when we need to keep the running sum, we can use the reduce function over an array. You remember the exercise of finding the initial letters, putting together initial letters of different words? It can also be done with the reduce. So we are not limited to numbers. When I describe the reduce function, I just said values. These values could be anything. Okay, so for example, all the initials of the people from all the answers, for example, can be computed by q1.answers. Let's extract the usernames. So it would be map a.username. Oh, of course, I'm using a because it's the answer. It reminds me of the type of object that I have. Okay. And then this is a list of strings. I want to concatenate all the first letter of all the strings. Right? Reduce. I have the string for up to now plus the current username. I return str plus user. And I start with an empty string. Now be careful, this empty string is the second argument to reduce. It's not part of the body and it's not part of the arguments of the callback. And it should compute a string. No, it will. User is not user, it's a plus, sorry. It's a string concatenation here. And at the end, oh, sorry, not all the name, only the first letter. Yep. So you can build a string piece by piece. You can build an array piece by piece by picking different parts. Okay, for building an array, probably you would use map, but okay. So the combination of these three. So you see why every and some are special case of reduce, because if you just put an and or an or operator there, you're doing actually, you're implementing those, okay? But of course, it's clearer if you write every or some. So actually, the combination of map and filter and reduce let us do most of the operation that we need to do on arrays. Of course, there are also some other methods that are less frequently used. But just as a, let's say, an approach for dealing with arrays, we try to use these methods because first, because they are convenient, they are easy to write, and second, because we have the guarantee that if we are programming this way, we are not creating any side effect. I'm calling a function that returns an array, and inside it will call a callback function that takes an element and returns some small computed value about that element. There's no assignment here, okay? There's no modification here. And this also leaves the room for the optimizer to do things in parallel, because there's no dependency between them, except from reduce. So if we go back to our exercise, where we had to implement a set of functionality, let's see if we can modify or simplify them by using these new functions. Okay, implement the following methods in the question object. Okay, add. This one is a typical operation that cannot be done functionally because it actually requires us to modify an array. It wouldn't make any sense of returning a new array because the array of answers should be inside the question object. So that's okay. We already implemented that in the previous hour with just a simple push, and there's no other way. This is a method with side effects, and we can't avoid it. A different specification would be to create a new question object with an added answer. So we copy over the question object, and in the new version we add a new answer. That would be a functional way of doing that. Find username returns all the answers of a given person. That you already implemented that in with a loop and a flag and an array to return, a temporary array to return. The exercise calls for returning all the answers objects of a given person given by an argument. So we could also implement this with functional methods. It would be just one line of code. So this.find would be a method that receives a name of a person and then returns what? The list of answers objects of that person. So it would be this dot answers dot filter all the answers whose name matches the name given as a parameter. Okay, we take the answers for this object and we have a callback. You see, here we have an example of the closures that we mentioned last time. Because now in the callback of filter, we are using name, which is a variable of the surrounding context. Name is not a parameter of this is a function, okay? The only parameter of this function is a. But the function inside is also using name, which is a variable defined in the outer context. Okay, never mind. By the way, also this return, since this body only have one instruction, which is a return, could also be dropped if you drop also the curly braces. So it will be something like this. And I drop also this curly brace here. And we should also find, there was some test for finding. Let's see. Let's maybe go into debug mode so that we don't print everything. Okay, you see that I went into debug mode, I put a breakpoint here, so that I just executed this find, which is now the new definition. And the answer found, before printing it, I see that you see that it checks all the two answers. Sorry, the two answers given by username Luigi. And of course, I can print it, and it will show it. By the way, all these functional methods don't care too much if the array is empty. they behave well. So for example, if a filter doesn't find any element that matches the Boolean condition, it will return an empty array. If you are applying them onto an empty array, they will return normally an empty array. The reduce will return the initial value as the final value, and so on. So we don't also, in many cases, we don't need to check for special cases. Another implementation that was asked for returns an array of answers after the given date. Or sorted by increasing date, or listed by decreasing score. So let's implement this one, the last one, and because I don't want to deal with dates right now. List by score returns an array of answers. Returns an array of answers. Means a new array of answers. Okay? So I want to implement this method, this dot list by score, and that doesn't have any argument, so it's just a function with no arguments, and the body is well, in this case, we need to do a sort, and sort is not a functional method by itself. Because it needs to modify and to work on the array as a whole. So we cannot do that element by element. And so in this case, we have just to sort, make a copy of the array and sort it according to this criteria. And we remember that sorting numbers requires a callback that will tell us how to compare numbers. So this means taking a result as a new array, which is a copy of this dot answers. So we make a copy of the answers, and we sort this result by comparing two answers, A1 and A2, by the difference of their respective scores, A1.score minus A2.score. And then we can return this result. Right, yeah. And nothing modifies the original object in this case. We are just returning a new array. Let's try to call it. Const sorted scores equal to q1 dot list by score. And again, let's print a breakpoint here. And we see the sorted score. You see the debugger window, you have the 6 answers, which is all of them. So it's sorted by score 3, 5, 5, 5, 6, 7. Sorting by date, it would be the same. Okay, in this case, the dates are how do we build them? Are just strings, okay? So we can compare them as strings. Another option would be, but this is not the decision that was taken in this exercise. When building these objects, in the previous hour, you decided to store dates as strings. So you can do a string comparison. Otherwise, you could have stored them as date.js objects. So that would mean, instead of storing the string, creating the date.js object with year, month, and day, and storing the object, and here just storing date.js and not converting it to a string date. And at that point, the comparison would have to be done with the method for comparing dates of the date.js library. So there will be a compare method for comparing two dates. So we should always be careful when we are comparing or sorting to be aware of the type of object that we have. In this case, date is a string, and this date is a string, an ISO string in ISO format, year-month-day, and so we deal it in this way. Otherwise, it would be like we have here in the print statements. You see, if you create a date.js object, it's no longer a string. It would have many fields, like here. And then you need to compare them. We need to look up at the documentation of the JS, what is a comparison function that returns negative, 0, or positive according to the difference of two dates. But in this case, they are strings, because when we create them, except the first one, it's a bit of a problem, because now we have an array with dates. Some of them are one of them is an object, and the others are strings. So in this case, it would be better to have all strings. Otherwise, I'm not responsible for the conversion. So I wouldn't know what is the comparison between this and this inside of sort statement, how to compare them. We could also try it, but then we'll be importing the JS into the console. It would take time. So let's be sure first that all the elements are the same type, and we can implement the method that is called list by date, which is the same as list by score. I just changed the syntax. This syntax is the same as this one, just as you prefer. Let's try to use some of them all of them just to train our eyes. And the implementation would be the same, except that we should have the comparison of the date. But we can do this. We cannot do this, because dates cannot be subtracted. So it's a bit boring, this one, because we need a function that returns a negative value if a date is less than another, or positive, or 0. So if there are numbers, it's easy. If there are strings, it isn't. We cannot even write something like this. A date less than other date. Because less than will return 1 if the second is greater, okay, but will return 0, false, if they are equal or the first one is less. So the result of the sorting will be wrong. So unfortunately, we have to break it down ourselves. So this is a case in which we need to be boring and say if A1 is less than A2, then return -1, as if A1 is greater than A2, sorry, the parentheses. Return +1, as return 0. And, sorry, not A1 and A2, but A1.date. Because the callback wants a function that returns a negative if the first argument is less than the second, 0 is or equal, and a positive value otherwise. If omitted, the elements are sorted in ascending ASCII character order, but the problem is that we don't have a list of an array of strings here. We have an array of objects. So that it would convert the object to string and then compare the strings. And we know how the string representation of the object looks like. It would compare, come here, strings like this. This is a string representation of an object, and they will compare to the string representation of another, if we don't provide a comparison function, which is not what we want. We could extract the string. We could do a map just having the dates. It's easy to have an array of dates, and we can sort the array of dates, but then we don't have the array of answers. So it's inconvenient. Strings don't have a compare methods. Remember in Java we have a compare to that returns for each predefined object already a negative, 0, or positive, but we don't have it here. We have it we must build it on our own. So strangely, for using the string comparison, which is the default for sort, we have to do extra work. Okay, because a string comparison over a field and not over the whole object. In many cases, you will see this written using the ugly ternary operator. So it will be something like sort with A1 and A2. And then it will return, since it's just a single return statement, we try to compact it in an expression. If A1.date is less then A2.date, then return -1, else check if A1.date is greater than A2.date, then return +1, else return 0. So question mark here. And let's put a parenthesis here, which is sorry, let's allow it like this. No, sorry, okay. Sort, open, yeah. It's an alternative way of doing the same thing with a more compact way, because we are using the ternary operator, question mark, colon, as a sort of embedded if. Unfortunately, we'll use that a lot when we are doing React, so let's just refresh it, because we don't saw. This is an expression, this is a ternary operator, okay? The first argument of the operator is a Boolean value, The second argument is the value returned if this boolean is true. And the third argument, let's for the moment not look at it, is the value returned if the boolean is false. So it's sort of a return -1 if this is true, otherwise return that stuff. And that stuff, in turn, is another ternary operator that, in the case this is true, it returns 1, otherwise returns 0. All of this is just an expression, like 3 + 1, and so it can be the body of a callback function, and the body of this callback. Is totally unreadable. Writing this kind of expression is very compact. It brings me back to the time where people were trying to squeeze as many strange things into C statements. So totally not readable. So in this case, I wouldn't suggest it. Probably it's easier the first one. Maybe putting a comment is not bad. Like sorting the array by date, considering dates as strings. Yeah, and but as I mentioned, when playing with React, we'll use a lot of this for saying, okay, in a web page there is this content or that other content depending on some condition. Okay, you enter data, so you can have the answer, otherwise not. So each page will be generated by a function. So instead of having many ifs, you can just conditionally render, we use this term, a part of the page, according to a condition, to a Boolean condition. Okay, the same game should be done, but it's easier, for the last method that we want to implement, the after date, return an array of answers after the given date. And this is the job for a filter, very simply. So after date, this dot after date with a given date as an argument is a function that takes this argument and returns, well, just a very simple filter. Dates are strings, we can compare them. We can just check if a date is greater or smaller than another. It's the same as we did here for filtering by name. Only in this case we are filtering by date. So it will be this dot answers dot filter, and the condition is from an answer, check whether the answer dot date is greater than the date given as an argument. So this is an example of an object where you have a method for deleting some elements. So we don't use the word delete in functional programming. We use return a subset. Return a new array where some of the elements are not there anymore. Okay? Okay, so let's get used to this way, and in the first lab we will have to start working on building some objects for the exercise that you chose and some basic function on this list of these objects. Okay? if you have any questions. Otherwise, I just want to mention that this is the basis, okay, functional programming is the basis for asynchronous programming, okay? Now, what we did was totally synchronous. I know exactly when this callback is going to be called, okay? I could convert every statement here into a for loop, and I have the full control. And the order in which the operations are done is exactly the same, okay? So it may be a bit strange because I'm defining a function here, and this function calls a second function, and this second function will be called later, but I have the full control over that, okay? But this method could also allow me to say, okay, I'm giving you a function, and call it when it will be possible to call it, because maybe right now you don't have the data yet, okay? So, in JavaScript, many operations, especially when we do with the network operation, so I'm sending something to a server and reading something from the server, also user action. The user clicks on a button, and something needs to happen. I have no control over when the user is going to click on that button. So the best I can do is to tell the button, please, when the user clicks you, then execute this function. So I'm setting up a callback that will be called in a moment that is also out of my control. It's asynchronous. So it's not synchronized with the rest of the instructions of the code. Asynchronous is not concurrent. We don't have here the problems that you have in the system programming course, where you have one CPU and all the threads that are insisting on the same memory locations and then trying to destroy everything that you see, okay? JavaScript is a single-threaded language. There is no parallelism in JavaScript. Only one instruction at a time can be run. But the language allows me for changing the order in which the operations are executed. Okay, so asynchronous is not a consequence of parallel. There's no parallelism here. Only one function at a time is being executed, and the unit of execution is the function. Once you start the function, that will run to the end. And it cannot be interrupted by any other asynchronous event. After the function is finished, JavaScript will check, oh, is there anything pending to do, and any other asynchronous function to call? And then that function will be called and executed wholly till the end. Okay? So it's a sort of a collaborative asynchronous execution model. If you write in a JavaScript, in a browser, an infinite loop, you are blocking the whole window, the whole browser. Because nothing else, not even clicking on a button, not even selecting text, may happen on that page. Because reacting to user events requires to call callbacks for handling those events, and if some function, let's call them, I'm not calling them threads because they are not threads, there's only one thread. If some function is running and is not releasing the control, is not returning, any other function cannot run until that, okay? So the model for writing asynchronous code is the same as callbacks. The only difference is that some callbacks will not be called right away, but will be scheduled for being called later on. This is the only difference. For example, the simplest asynchronous callback is the simplest asynchronous operation is a timer, where we want to schedule some operation to happen after some time. So there's a predefined function called setTimeout in JavaScript that requires two arguments. One is a callback handler, and the other is a timeout, a number. So what I'm saying is that I do something after a given time. Do something, I don't know, print something. I don't know, console.log, hi, after 1 second. The timeout is a number expressed in milliseconds. Delay in milliseconds. Okay? So, by the way, this is wrong. Be careful, just I wrote something wrong to show a point. This would be wrong from the syntax point of view, because in this case, this is not a callback. This is a function that will be executed. No, I'm calling the setTimeout function. It has two arguments. So what does JavaScript do? It evaluates all the arguments. So evaluating the first argument means executing this instruction. It will run immediately and return undefined. So the timeout will execute undefined after 1 second. What we actually want to do is to give to the timeout function a function. So evaluating this does not execute the log statement. It will only execute the function definition statement, expression. So the function is not called. It's just parsed and stored away. And the reference to this function is remembered. So I can then print something else and see what happens. It happens that statement 1 is executed before statement 2. But statement 1 doesn't print anything. Sorry, let's run it. Want to see it again? As soon as you run, it will print ABC, and then after a while, it will print hi. Okay, and you see that the node interpreter was waiting until the timeout, because it sees that something is still pending, so it doesn't want to exit yet. And so after 1 second, this is going to be printed. And if I set another timeout with a different value, they will come in an order that depends on the delay. So the order in which these functions are executed, these callbacks are called, doesn't depend in the order in which they are defined, but it depends on some external event. In this case, a timer ticking. Okay? And just to show the point, if I don't know. If I'm creating, you see, I forgot so I'm creating an infinite loop. So it printed ABC 1 second is long gone, but it doesn't print anything else. Okay, we'll see next time the model for doing that. But until the main function is executing, the other function that will be triggered for I need to be executed, but they won't be until the main thread or any other function is finished. Okay? So the basic concept is one function at a time and callbacks that will be called when some condition is met, when some external condition is met. Okay? So next week we'll play with those. Thank you.